And warmly welcome back for this element 7, chemical and biological agents. Even the word chemical have very deep meaning, and since we have millions of different kind of chemicals being used and applied in several processes within several companies, and it wouldn't be wrong if I gonna say we are occupied with chemicals actually. Even if we study our human body, even we'll found a lot of chemical reactions. If we talk about any sort of material, we'll see the chemistry of or the formula of different chemicals mixing together. Or if we talk about solid shapes, if we're going to talk about liquid shapes or kind of gases, the invisible enemies, we'll still can understand how deeper the meaning of chemical is. And in line with that, of course, we have plenty of biological agents we're going to discuss in element 7. So let's focus on, first of all, on chemical. It could be in solid shape or might be a liquid shape or in shape of gases. But if you remember, I always mention, the invisible enemies are more difficult to manage with. Like if H2S, hydrogen sulfide gas in shape of gas or colorless gas, heavier than air, and extremely flammable, extremely toxic, poisonous, having a certain level of LDL and UEL, also, extreme level of ignition temperature, and most importantly, it can kill in minutes and seconds, if the ppm level is ignored actually, or the gas testing is not being done, especially in our confined spaces. So managing different kind of chemicals is one of the most difficult job in the world, especially for the invisible chemicals. And invisible chemicals in high hazardous industries becoming more critical, like oil and gas. Within oil and gas, we have oil rig sites, refineries, gas oil separation plants. Even excavation is going on. Plenty of even for the residential compounds, plenty of confined spaces are there. We have drainage system, we have pipelines, we have several kind of silos and different kind of confined spaces. So that means the invisible chemicals in all restricted or prohibited areas, mostly we find, and how are we going to keep ourselves safe and to our employees or all the stakeholders is one of the greatest challenge, where we require a complete effective safety management system. Same way we are buying chemicals, so we must be familiar how to buy chemicals. We store chemicals, so our storage system must be brilliant all the way. And the same way, if we are the user of these chemicals, we have to be the safest user, the knowledgeable user of those chemicals. And same way, we talk about biological agents, that's another deeper technically sound subject, and one of the example is coronavirus, which I told you we'll discuss a little bit more about coronavirus, for this element 7. So let's talk about let's understand some of the objectives, learning objectives of this element as per NEBOSH theories. We truly have to understand the forms and the classification of the health risks and exposure to hazardous substances. We'll discuss how we're going to undertake the assessment, especially the health risk for commonly encountered, at the workplace because of these substances. We'll also discuss the use and limitations of occupational exposure, including purpose of long-term and short-term exposure. And once we have risk assessment or identification of several hazards related to chemical or biological agents, the key part again, the control measures, how we gonna reduce or bring it at acceptable or negligible level, which can reduce the possibility of ill health. And also we'll discuss in detail the hazardous risk and control associated with different kind of specific agents. So that these are the learning objectives. So let's start with 7.1, forms of classification of health the risk from hazardous substances. If you're doing sand blasting or kind of abrasive blasting, or if you're doing coating even, we are creating, something is going in the air in shape of combustible dust, in shape of corrosive dust, toxic dust. That's why the forms of chemical agents will find in solid like dust, even in fumes like gas, mist, vapors, liquid, and fibers. The physical form, of course, greatly affects the hazard presented and the route of entry into the body. So the real challenge is not to let these chemicals to inhale, to go in any way within our body, because the more toxic chemicals we're gonna inhale, that means less will be the oxygen. Like it will consume the existing oxygen from our body. So less the oxygen, more breathing issues, no oxygen, no life even. That means no messages from the brain and no pumping, the blood pumping from the heart. So it's all stuck. That is why several people are still dying if we don't have proper chemical management system in place, especially related to toxic gases, especially relevant to H2S or carbon monoxide or certain kind of LEL, UEL, which is a combination of overall the environment, including oxygen itself. Now, there are some sort of forms of biological agents like fungi, bacteria, and viruses are there. We have to be careful about these biological agents because they are a source of different kind of terrible diseases. Maybe the former's lung, maybe some Legionnaires or disease or leptospirosis, or maybe HIV, hepatitis B, and I added the word coronavirus as well. Now, of course, these chemicals or biological agents have acute and chronic effects, and that those effects could be short term, that means for a short period of time, and the long term effect could also be there. So let's understand the acute short term effects, maybe high levels of exposure, short exposure time, quick effect, exposure to high concentration of chlorine gas. Same with the chronic, long-term effect, lower levels of exposure, long exposure time like multiple exposure to asbestos. And I hope you remember I shared one of the story how this asbestos fiber can kill, the people who are working in textile industry and cement industry and construction even, especially for sailing work, especially for coating of certain pipes, or they're working, especially in construction for renovation projects. Like when we accept any project for renovation of any existing building, then asbestos containing material must be evaluated. Otherwise, those fibers, once gone into our lungs, no way to put them out actually. So ultimately, in the short term, might be will not face so much consequences, but long term, it's kind of a lung cancer. So that's why it's important to understand the classification of chemicals, the hazardous to health, like it could be physio-chemical effects, health effects, and environmental. So 3 domains of effects. Physiochemical means extremely or highly flammable, explosive, or oxidizing. Health effects could be toxic or maybe cancer as well, So environmental effects, harmful to the aquatic life. And there is European regulations, we call it EC number 1272, 2008 on classification, labeling, and packaging of substances mixture, like kind of a CLP regulation. So in UK, it is implemented, the European regulation. And now the true picture, the current picture, still we need to evaluate either UK is still bound to follow European regulations because they have no more alliance with Europe. So I think we can research and find out what other applicable standards are there locally instead of referring European regulations. But still, after finishing this alliance, if still they are respecting European regulations, that is up to UK's government or kind of top management. Now, the key part is how we're going to assess all these health hazards or kind of risk, because finding electrical hazards or doing assessment of certain kind of physical hazards is not a big deal. But the key point is how we can assess the health risk. That means more deeper study required. Now, to understand more deeper risk assessment of health risk, it's important to discuss how can a chemical or biological organism enter the body, and which is the highest risk route of entry and why. I'm opening the question in the chat box. How a chemical enters in our body? I'm waiting for your answers, please. Chemicals entry in our body. Can you just highlight chemicals entryways into our body? So how our body is getting those chemicals, and which is the highest risk route of entry and why? It's talking about chemicals or even biological organism, how they enter to our body. Take your time. I'm expecting some productive answers from your side. Okay, Mr. Muhammad Al Gamdi, excellent, mashallah. Inhalation means breathing. Okay. And also you will go with absorption, in other words, like through CNRI. Ingestion, okay. So that means inhalation, injection, and absorption. Now the next question is, which is the highest risk route of entry and why? Yes, A, B, ingestion, absorption, inhalation. The third one we can move on. And also injection. Now the next question is, which is the highest risk route of entry and why? Inhalation. Okay. And why? I totally agree, because some of the chemicals are odorless and with high impact, of course. And most importantly, why we say inhalation is the most common route of entry, because a chemical definitely can take into our body, and this could include, like, several other processes. They are giving us chemical dust, particles of mist, and of course they can be inhaled through our mouth and nose, and could be swallowed because of different kind of contaminated objects, because it's not like always one toxic gas, maybe a combination of different toxic gases, or contaminated air, in other words. That is why these contaminated air is not only polluting or damaging to the human health, even they are impacting to the food, they are impacting to the metals even, So a lot of several other terrible effects are there. So yes, we can say inhalation is the most common route of entry, a chemical to our body. Excellent, mashallah. No, so these are the routes of entry, like you mentioned, mashallah, inhalation. That means inhalable dust, all particles, respirable dust, only smaller particles, or ingestion, absorption, or injection. Injection does not mean needle stick only. It could be cuts and braces or bites even. Now, against all these four elements, against chemicals and biological agents, now we required some kind of protective defense mechanism. And we have, our body have basically two main defense mechanisms to combat attack by biological agents and damage by chemicals. And we call them, one is cellular and the second one is superficial actually. Cellular means the internal defense and superficial means the external defense. Let's talk about internal defense. That means the cells fight bacteria and other toxin from blood, respiratory and ingestion entry routes. Here we can again incorporate example of coronavirus. The people, anyone whose immunity system was strong enough have no issue mostly with the coronavirus, because his internal defense system is so much strong, so he can fight back with all the terrible effects of coronavirus until, he does something terrible or he ignores some health practices. Otherwise, his internal defense system is enough. That means his internal immunity system can fight against coronavirus, and that is why the young people, mostly having strong immunity system, we rarely see that the young people are died because of coronavirus. But those who were drinking alcohol or having some bad habit of like a chain smoker, or the people whose lifestyle was terrible, even though they were young, still caught by coronavirus, because their immunity system was already demolishing because of their bad lifestyle. Otherwise, we have superficial, that means external defense, which protect against toxins and enter through the skin and contaminants in the nose and throat. That is why we have a disposable mask or respiratory, different kind of mask available just to protect that toxins shouldn't go, or enter to our skin or contaminant. That is why we have even, we call it, the complete uniform. I mean, especially for the welders like FRC, fire resistant clothing, or even to avoid certain impacts of the chemical, separate coveralls for the people who are directly managing to the chemicals. So their PPs are entirely different in nature as per the requirement, or they are suitable to the process. And also as per the STS or kind of MSTS, material safety data sheet. We also have respiratory defenses. That means sneeze reflex or filtration in nasal cavity. This is kind of, I would say, the natural system, our Allah, mashallah, have well established. And mucociliary accelerator or macrophages, phagocytes or inflammatory response. So that means if that our respiratory defense, if it's okay enough, again, is good to especially to fight against coronavirus, because coronavirus, if it is impacting or terribly affecting to our lungs, and our breathing system is suffering badly, very less chances of survival. That's why the people who have faced the terrible effect of coronavirus on their lungs and it's penetrated and couldn't control, and they couldn't survive for 14 days and it's not died. Even, the coronavirus, they fought for 14 days, but still their lungs are affected terribly. And still they have some issues, even after recovery, even though they are survived, they are not died by the coronavirus, but still they don't have the similar kind of health level, And also we have skin defenses like a waterproof barrier comprised of outlayer. We call it epidermis. Again, Allah have given all these, good formulation to our body. Inner layer, dermis, and defense mechanism include replenishment of dead cells or sebum. We call it biocidal properties, and that means these three layers still are helping. So if you ever, the people who have habit of exercise or jogging or walking or something like that, and their body is strong enough, or they have more fiber intake or iron intake, that means more better skin defense. And same way, the inflammatory response is also there. Now, how are we going to assess the health risk? So we can follow 6 steps. The number 1 is no harm to prepare the list of hazardous substances. That means we have to identify how many hazardous substances are present in our company, especially process to process, area wise, all need to be identified. Invisible, even in shape of gases, we have to identify. And also we need to identify the people who might potentially be exposed actually. So list of hazardous substances in any shape, could be in liquid shape, solid, or even, the gases, the invisible enemies, but we have to identify them. And along with that, the employees or the people who could be, potentially captured or exposed to those hazardous substances. Then the second step is collect the information or gather information about the substance. And this information, either you get SDS or you get TDS, or that means safety data sheet or technical data sheet, or if you're working with Saudi Aramco, so maybe CHB, chemical hazard bulletin. So you maximum collect the information about that substance or kind of chemical. Or you get help even from the chemical engineers, might be they could help you in a more better shape, how to tackle, how to identify, how to put some better controls against this substance. And accordingly, you can evaluate. That means how terrible it could be affecting to our health. No harm to have a complete risk rating, through our evaluation process. Then identify any controls needed and implement them. Record the assessment and action taken and review. So these are 6 steps. How are you going to tackle health risk? Now, the key points are hazardous nature of substances, potential ill health effects could be there, physical forms, routes of entry, quantity is important, concentration, like the concentration of H2S, what is the ppm level, the concentration of carbon monoxide or ammonia or methane, what is the concentration, how much it is available in the air, especially in confined spaces, especially in restricted areas, or number of people could be affected because of that terrible concentration, or frequency of exposure and duration of exposure, control measures. So these are further steps to make sure that we are having a capable system to assess the health risk and to put some effective controls in place. And in one of the project, let me share with you that in the safety committee, we hired one of the doctor, even though he was employed internally already, but we put him as a team member in the safety committee, and he was a great helper and, assisting us how terrible health risk could be there because of H2S, because of ammonia, because of some fumes coming from the welding process, maybe coming from the several machines. So it's up to us what kind of experts we have in our safety committee, so then we could plan better health, the controls against any risk. Or otherwise we can get help from WHO, the World Health Organization. If you want to, fight back against coronavirus, the best theories we can take from WHO, how we have to fight back, and same from CDC, and even in Saudi Arabia, from Ministry of Health, they also have a lot of solid approach. That is why, mashallah, Saudi Arabia is one of the best country, mashallah, in the world in controlling coronavirus. I mean, how focused they are, and now the things are getting normal, mashallah. Now the product labels are critical. Imagine if you are going to buy some medicine and the label is not there. Even the selling person is saying, oh, this is exact the medicine you're looking for, but label is missing. Are you going to buy? Of course not. Will you accept? Never, because labels are important. On the label, you want to see, what is the name of the substance or the mixture. Same way, if you're buying chemicals, or even let me give you an example of simple water. You are buying Nestle water, but label is not there. Will you accept it? Of course not. That is why the hazard communication, especially the labeling of each material packed in any shape, is very much important. And based on globally recognized standards, the labeling, even in Saudi Arabia, they also have some specific labeling requirements for food items, for pharmaceutical like medicines and several chemicals also. Now, set requirements, that means the name of the substance, the mixture, hazardous components, risk phases indicating danger, and precaution details of supplier. The product label must be there, and there is an example you can see in the picture. Like sulfuric acid. Now, as per HEC guidance note EH40, the sets UK legal workplace exposure limits, WAL, and maximum concentration of airborne substances, and EU list of indicative limit values also given in the EU legal limit values for 19 chemical agents. And also we can find some informations as a guiding document from American Conference of Government, Industrial Hygienists, threshold limit values, even though these are the guidelines, not the legal standards. The choice is ours. We want to follow them if we believe it's a great help, and we can have some understanding to know how to follow them. But the first thing is our local standards, like the Saudi Arabian regulations or certain chemicals. What are the limits? The permissible limits, or above than permissible limits, that means it's a violation. Automatically, if caught by the government officials, the warning will be there, or maybe some fine policy would also be enforced. Now the question is, outline the type of information you would need to know about a domestic weed killer in order to assess the risk. I'm opening this question into chat box. The point is, what type of information you required against domestic weed killer? Type of informations against domestic weed killer. What information you need actually? Take your time. So mostly what kind of information we required? Like you are buying some domestic weed killer, some products from the market, and you are going to do risk assessment. So what kind of information would you know? Would you need to know about a domestic weed killer in order to assess the risk? Because any chemical you are buying, or any sort of chemical in shape of gas or in shape of liquid, or even in solid shape, of course, you required some comprehensive information. So then you can assess the risk. And without effective assessment of risk or kind of risk assessment, how come you can implement some better controls, in place to fight back against these risks and keeping your employees safe, Outline the type of information you would need to know about a domestic weed killer in order to assess the risk. I mean, just consider you guys are going to do risk assessment of domestic weed killer. So how are you going to perform it? Of course, you have to find some information and then move on with next steps. That is why it is asked, what is the type of information you need to know about a domestic weed killer in order to assess the risk? And why the weed killers are harmful? Because it can definitely be harmful by containing some swelling, and also some people are unable to fight back because of low immunity level, and it's also contained terrible agents of several chemicals. So even though it's a formula, it's being used in several countries, especially in UK also, but having very much terrible biological effects. I can give you some examples, maybe genetic damages, maybe physiological alterations. Even some cases we can find, the people was died because of this weed killers organism exposed, That means this is very much harmful for human body. And sometimes I say, at our home, we spray a lot of different kind of pesticides, and without realizing how dangerous they could be if you are filling your house with over quantity. I mean, how they could be having some kind of irritation to your eyes, nose, and throat. And sometimes they can also affect on your central nervous system, including the kidneys. And that means the more chances of more risk of cancer. And some of the systems against such kind of household pesticides, including this domestic weed killer, we might face some headache, or dizziness, or maybe some weakness and nausea, or muscular weakness, I would say. So that is why it's important topic to research, to browse, to find out maximum informations and understand why we need to do risk assessment of chemicals. And sometimes I suggest to the companies, don't, even though you have a master register for risk assessment, but still chop up the elephant and create some further risk assessments. Might be risk assessment of chemicals, risk assessment like fire risk assessment, or maybe you can have general risk assessment, or maybe you can target one machine. Oh, this is machine number 999 risk assessment. You can find maybe one material only, and you can create a separate risk assessment of that particular material. So it would be more easy for you to target the sensitive materials, equipments, or areas even, or kind of processes And once your risk assessment is done effectively in coordination with the relevant department, more easier for you to put some comprehensive controls and make sure there is very less chances of incidents or accidents or injuries within that area or within that line of fire of that process, So let me be straightforward here. If you have more than 100 chemicals within your company, so make sure you have 100 SDS, like safety data sheets. And within the safety data sheets, you will find 16 different kind of informations. And those informations will help you to understand, how that chemical number 1, chemical number 2 or 3 or 4, chemical wise, what are the risks which can be terribly harmful for our employees and how we have to use them. Because within that SDS, you will find 16 sections, same like we have previously in MSD, like material safety data sheet. Now the new name is like SDS, safety data sheet. That means these 16 sections, informations must be there for our better understanding, like identification of substances in supply, what hazards could be there of that chemical, composition of ingredients, that means the formula of that chemical, first aid measures, if it is touched to our eyes or inhalation or touching to our skin. So what are the first aid measures? Or firefighting measures, how are we gonna fight this chemical if the fire incident is there because of that chemical, accidental release measures, how to control that one. Handling and storage, exposure controls and PPs and physical chemical properties, stability and reactivity, toxicology information, ecological disposal consideration also, and transport information, regulatory information and other information. And if you are the manufacturer of chemical, all 16 section informations you have to publish. You have to publish for the awareness and understanding of the end user or the buyer, whosoever is there. And there are plenty of chemical regulatory bodies and all 16 sections. That means the technical file of that chemical must be complying with European regulations or international standards. It's not like just anything you will write there. It must be provable. So all 16 sections will help you to conduct a very detailed, comprehensive risk assessment of that particular chemical. Yes, there are limitations of information, like might be information sources provide just general kind of information, but don't consider the specific conditions of use. And it could be like individual susceptibility or mixed exposure or based on current knowledge as well. So there are limitations for sure. Now, how are we going to monitor them? Because the role of hazardous substances monitoring personal exposure to hazardous substances is sometimes necessary to quantify the concentration of a substance that a worker is potentially exposed to. Like if you are sending one gentleman in the confined space, so make sure what is the level of oxygen, what is the level of H2S, and any chances of carbon monoxide, and what is LDL, lower explosive limit within that area, or some other toxic gases, And then you're gonna evaluate either you can send this gentleman without scuba, without any respiratory protection, and for how many hours you're gonna send, if it is all under control and under permissible limits. And if it is out of permissible limits, what kind of precautions, controls, or kind of PPs you have to provide to that gentleman. Let's take an example. For example, personal dosimeter for dust exposure. A filter and air pump is worn by worker while working, gives average value over time. Same way, while doing abrasive blasting or doing some spray painting or kind of coating or several other processes are there, especially in the confined space. We have specific, technically sound, appropriate PPs for them. Now, what is the role of hazardous substances monitoring? Failure or deterioration of the controls can result in serious health effects. That is why, to ensure OEL or WL is not exceeded, to check effectiveness of control measures after any change occurs, which could affect control. So, working exposure limits must be, not to be violated actually. Now, limitations of hazardous substances monitoring. Accuracy of results is critically important. Yes, variations in personal exposure might be habits and bad practices or best practices, human to human, employee to employee, everyone is different. So you never know which brain is going to do some silly things, So absence of a standard might be not everything. Not everything has a limit. So other exposure routes monitoring focuses only on airborne contaminants. So these are some of the limitations of hazardous substances monitoring. We already discussed what are the 4 main routes of entry chemicals into a body, how the respiratory system defended, and what information would you find on a safety data sheet, like all 16 sections we discussed already in the presentation. Now, this is the most important topic because the exposure limits, occupational exposure limits. Any one of you is familiar what is the PL of H2S in a confined space? PL of H2S, permissible exposure limit of H2S. Any one of you is familiar, especially in the confined space? Please, let's refresh our knowledge, Permissible exposure limit of H2S. Yes, guys. Permissible exposure limit of H2S. Okay, in a confined space. Let me be more specific. Yes, please. Permissible exposure limit of H2S in a confined space. You can speak up also, it's up to you. You want to write something, you want to speak, you can unmute your mic or you can write in the chat box. It's up to you. But we will not move on until we understand our understanding about occupational exposure limits. Let's take few examples like we started from H2S. What is the permissible limit of H2S in a confined space? Yes, please. Permissible exposure limit of H2S in a confined space. Like 1% is equal to 10,000 ppm. And 10% what you mentioned means 100,000 ppm. And on the other side, 1,000 ppm is enough to kill a person in minutes, you know. That means goodbye. Sure, Avi, you're absolutely right. You know, even the ideal H of H2S, immediately dangerous to life or health, is 100 ppm. That means after 100 ppm, already you cross the line of fire. So yes, Mr. Hamad, absolutely right. Below 10 ppm, but the ideal environment is 0 ppm. I'm not trying to make this discussion more lengthy, otherwise I will start another technical debate. How we will ensure 0% ppm? How are we gonna remove H2S from confined space or all other, you know, LEL or kind of other toxic gases or fumes like carbon monoxide, like, you know, other toxic elements? How are we gonna make sure even LEL is 0%, or like you are using, okay, LEN and UEL, lower explosive limit and upper explosive limit. And imagine AB, if you are doing hot work, what could be the LEL, you know, in a confined space? Yes, absolutely. LEL basically is a combination, you know, whatever is available in the air, accordingly, it would be a cumulative rating of all the available ingredients in shape of gases, mostly. And will give you the LDL reading. Now, my question is, if you are doing hot work like grinding, cutting, abrasive blasting, or any process which can create some ignition source, what should be the LDL in the confined space? Okay, let's create this is as a second question. LDL. Okay, excellent, Marshall. So LDL should be 0%. LEL must be 0% all the time while you're performing hot work. That is why sometimes we have continuous gas monitoring. We have better ventilation system or extraction system, you know. And we also make sure, you know, before we start our project, we isolate all sort of energies. Could be electrical, mechanical, gravity, motion, pressure, any kind of energies, or any toxic hazardous substances, including H2S or any liquid coming to that confined space. We remove them all, we drain it out, we isolate, we disconnect basically, we use blinding or disconnection. And then we wash your water, you know, water wash or maybe streaming. And later on might be gonna use purging also by using nitrogen. And what we are doing, we are bringing LDL at 0 level. And yes, we must use fire blanket wherever applicable. Excellent. So what is important here? Occupational exposure limits around the world. There are different occupational exposure limits like OEL. For hazardous substances, there is no global standard in the UK. They are called workplace exposure limits like WELS. That means WELS. That is in the UK. They are called workplace exposure limits. They set a maximum limit of exposure that can't be exceeded over a given time period. Well, they have legal status under the COSH regulations. What is the definition of WL as per UK? The maximum concentration of an airborne substance averaged over a reference period to which employees may be exposed by inhalation. Few examples: short-term exposure limits, STEL, time period 15 minutes, and reasons for limit: combat acute effects, very high exposure for a short time. And long-term exposure, we call it exposure limit, LTEL, that means 8 hours. It comes back with chronic effects, lower exposure over longer period. So we have short-term and long-term limits. AB, this COSH regulations basically is kind of a, I would say, chemical, analysis body of UK, which help and prepare several kind of chemical theories and kind of research against chemicals, and also gave a lot of guidance to the market, and we call it control of substances like hazardous to health regulations. So they are a regulatory body of UK, that is why they refer we follow COSH regulations, because they are only working for hazardous substances, especially to control them, like control of substances, hazardous to health regulations. And if you follow COSH regulations, it will also help you to, keep safe your employees and several conditions by following WL, workplace, exposure limits, well defined by COSH regulations. So country-wise, there are regulatory bodies locally available, but in UK it's kind of COSH, that means control of substances, hazardous to health regulations. Now, what is the purpose of time-weighted averages? The purpose is quite clear. The worker might be exposed to different levels. It's not like always the same levels. There could be some different levels of hazardous substances throughout the working day. That is why the STEL, that means short-term exposure limit, and long-term exposure limit, LTEL. LTEL or STEL prevent them being exposed to harmful levels of substance over a short period of time, where this would cause acute effects. The LTA, the long-term exposure limit prevents them being exposed to harmful levels over the full working day, where this could cause chronic effects. So we can't allow people to work continuously in toxic environment. So in the COSH regulations, you will find for sure, the working exposure limits for different chemicals, and most importantly, if you have STS of each chemical, it would also be helping you. But still, COSH regulations are helping us, and I'll try my level best to download them and send you in the WhatsApp group, inshallah. Let me note down. So I will share this, and let me tell you that I will share might be one link also, and you can attend a lot of free of cost courses by COSH UK, because they have created that free awareness not only for the UK nationals, even globally. So I'll try my level best to share that link, and might be more than 20 different courses related to chemicals or several safety systems, you can attend free of cost and you can have a certificate also. So I'll try my level best to share that link also, for your, whenever you get time, might be after achieving your NEBOSH qualification or whenever you believe you have sufficient time, and just enroll, subscribe, and attend all the courses one by one. And the way they teach is excellent, especially for the chemicals, and it will give you a comprehensive skill how to conduct risk assessment of several chemicals. So I'll share both like the regulations as well as the training link, and it will give you a comprehensive understanding about chemicals, inshallah. And most importantly, in the UK, plenty of other free of cost training institutes are there, online available. So whatever I have in my knowledge, I'll try to share in the WhatsApp group, but it's up to you when you're gonna get some time, inshallah, to attend and to learn more. Now, limitations of exposure limit, like being below a limit, does not prove it is safe. Only concerned with inhalation, no account of individual sensitivity or susceptibility, no account of synergistic or combined effects, invalid of normal environmental conditions change. Some limits do not consider all possible health effects of a substance. Like one of the incident, if I remember exactly, the persons were doing, this spray painting in a confined space, kind of a room, underground. And they painted probably in one shift for 6 or 8 hours, and then the second shift guys came and they were having another job, and no gas testing was there, no PPs they used. They have no idea this this confined space or this room is already occupied with toxic fumes, and might be some toxic gases could also be there. And now the terrible mistake they did, they started smoking. What they thought, first let's smoke and then we're gonna start our job. And this is kind of a shocking point for me. While smoking, nothing was happened, but the moment they threw up this cigarette butt on ground, and still ignition was there, and immediately fire started, because H2S and some heavy gases mostly sit in the bottom, instead of in the middle or at the top, So because it was in the lower areas, so the moment he threw that cigarette butt and the ignition was still there, and suddenly fire broke out, and then he, started pushing up with his safety boot. That means more fuel given to that fire, and immediately that fire broke out and got even uncontrolled, and the both guys died immediately. And it's not like always only the health issues, even overall safety could be a challenging, especially in the confined spaces, because we don't want to see any fatalities or God forbid any kind of major accidents or incidents which can destroy our business, our goodwill, or also our most important assets, means our employees. That is why it is important to understand some of the international standards. Like mentioned earlier, workplace exposure limits from UK, indicative limit values from EU, and from USA, what we can get? The American Conference of Industrial Hygienists, like ACGIH, sets threshold limit values. We can get whenever we want to see TLVs of several chemicals, we can go to ACGIH. If you want to see some of the, NIOSH approved some standards, like National Institute of Occupational Safety and Health, and a lot of NIOSH approved PPs you're going to find, especially the respirators. recommended exposure limits, REL. And the American Industrial Hygienic Association, AIHA, has developed workplace environmental exposures. We call them WHEELs also. The Exposure Safety and Health Administration, like OSHA, enforces Department of Labor permissible exposure limits like PELs. So PEL is more important under OSHA, REL more important under NIOSH. If you want to get some information for TLV, you can visit ACGIH, and they all have their websites, updated standards you're gonna find there. Now it is up to you. You can take a screenshot, or might be you can note down and start researching, you know, what they're guiding us. It's not like only to pass the NEBOSH exam, you know. It's now become like more practical, that you don't talk anything without reference, you don't implement any standard without solid reference, you don't go for meetings without better homework, you can't talk beyond the standards, because you have to give some reference why you are saying, oh, this is PP must be provided, or this regulation must be followed, or this SOP need to be updated as per those standards, you know. So once you will start talking in reference with the standards, nobody can challenge you, inshallah. In meetings and toolbox meetings and auditing times, or especially with third-party auditors, with your second-party auditors, or even with your internal auditors also. And it will give you a very broad vision. That means there are standards for everything. We talk about process, material, we talk about any kind of chemical, there are particular standards. Now it is up to us how much we want to learn. It's like a sea, you know, it's like an ocean. That was all about what are the OELs, what are they known in the UK, and what is the difference between an 8 hours time weighted average and 50-minute STL. We all discussed in the presentation. Now, this is another most important subpart of element 7, like 7.4, control measures, because ultimately the risk assessment, the hazard recognition would have no value if you don't put some comprehensive controls against them in. That is why the control hierarchy, or kind of control measures, we have to understand. So let's start. The need to prevent or control exposure. Prevention of exposure is the best. Prevention is better than cure, you know. The much better strategy is, don't let your people to expose to those sensitive, restricted, prohibited areas more frequently, and don't allow them without proper work permit, without proper permissions. And make sure, if it is not possible, then adequately control it, you know. If you can't like prevent exposure, then make sure you have adequate controls well in place, and ensure WEL or OEL working exposure limit or occupational exposure limits are not exceeded. If they're exceeded, it's kind of a violation. If something happens, authorities will dig out the reasons what happened exactly, you know. These are some of the principles of good practice, like minimize emission, release and spread of hazardous substances. Like if someone is doing painting and the other one is doing welding and someone is doing abrasive blasting, all the workers have to be at least familiar what is going in the air. And if they are working in a restricted area, then it became more sensitive. We call it simultaneous operations at some level. The different activities are going all together, or maybe same activity is being managed with different machines, or maybe different kind of process technologies, you know. So simultaneous operation, the risk assessment of simultaneous operations, it's more critical, you know. It's not easy, especially in offshore industries. Now consider routes of exposure and use control proportionate to the risk. Choose effective and reliable control measures. Use PPs where control cannot be achieved by other means. Same things, you know, hierarchy of control you need to apply. Inform and train employees, ensure new control measures do not increase overall risk. And what regulations you have to follow? The control of substances, hazardous to health regulations, Schedule 2A. Okay, so the COSH regulations will be helping you for managing chemicals, all sort of risk or hazards. Now, this kind of a group exercise, a gardener is spraying a weed killer in a domestic gardener in windy conditions. The gardener has no means of washing his hands, and the house owners have children and a dog. The weed killer is an organophosphate or labeled toxic. Using the hierarchy of control, discuss how the risk may be reduced. Imagine this is kind of a scenario that a gardener is spraying a weed killer in domestic gardener. Nearby, of course, no washing station. He can't wash his hands. Even the house owners have children and dog. And also the weed killer is quite labeled with toxic, that is dangerous. So what hierarchy of control you're gonna implement? So can you discuss in the chat box? Look at the scenario and just hierarchy of control you need to discuss. Is there any chance of elimination, substitution, administrative controls, engineering controls, administrative or PPs? How you can reduce the risk? Risk to the dog, risk to the children, or risk to some other elements of that house, not to contaminate the air, not to kill several other things, like not to reduce even the oxygen level. So how are you going to control, how are you going to bring down the risk at acceptable level or negligible level? How you would implement hierarchy of control? So in quick nutshell, let me just mention few of the things. These are some of the control of exposure, like elimination or substitution. You can try for it. You're going to have some change in the process, so reduce exposure time. You can have some enclosure and segregation or local exhaust ventilation, LEV, dilution ventilation, respiratory protective equipment, other PPs, personal hygiene and protection regimes or health surveillance. So these are some of the practical control of exposure. Now let's discuss one by one, like if you want to eliminate or substitute, what we have to do. Like you can eliminate process, might be outsource painting. You can change work or maybe screw rather than glue. You can dispose of unwanted stock. So less chances of further fumes to be in the air. Substitute hazardous for non-hazardous, like irritant to non-hazardous floor cleaner or corrosive to irritant. We are talking about elimination or substitution. Change physical form of substance to one that's less harmful. Otherwise, change the process. Apply solvent by brush instead of spraying, because spray means more fumes in the air. Vacuum rather than sweep. Reduce exposure time. This is another best strategy. Double the time, double the dose, half the time, half the dose. So minimize the time period over which people are working with hazardous substances. This is called administrative control also. You are making some rules and regulations and implementing them. Linked to OEL, occupational exposure limits as well. Enclosure and segregation, like totally enclose the substance, prevent access to, or keep people away or designated area. So you have enclosure and segregation controls also. Look at the local exhaust ventilation. Like branch ducting is going on, hood is there, main ducting, Air filter you can put in place, dust collection bag could also be there. And then you also have extractor fan and discharge to the atmosphere. But even that discharge to the quantity of that discharge to the atmosphere still should not violate the environmental regulations, Now discuss how the effectiveness of LEV may be reduced. So these are some of the local exhaust ventilation. How are we going to reduce? Poorly positioned intake hoods, damaged ducts, excessive amounts of contamination, ineffective fan, blocked filters, buildup of contaminant in the ducts, sharp bends in the duct, or unauthorized addition to the system. So yes, ventilation will definitely be affected, or we can improve if we can avoid all these issues, which is not easy, by the way, because normally our maintenance teams, sometimes they don't take everything seriously, They always believe, oh, this is acceptable. This safety gentleman always behind us. They have no idea how it could be terrible, Like, let me give you one example of my house in Pakistan. I designed my house just at one word, the ventilation. I asked the designer, even the, architect or construction or civil engineers, I mentioned them clearly. I need only ventilation, not to be compromised anywhere within my house. So the whole house is designed on ventilation. Now, what are the benefits? Throughout the day, we don't need light because sun lighting is, reachable everywhere within the house. The drainage system, we didn't mix up the lines. Every line is separately going into the, the drainage system actually. Even no mixing with the toilets, that all the rooms have toilets, but a separate line up to the drainage system, We didn't mix, no joint within the same way. We tried our level best, make sure, the window size is not the regular size. We took it like more bigger sizes because we are living in a very natural environment. Nearby we have a lot of trees, and the canal is going on, the bigger canal of Punjab, Pakistan. And I always mention, you are the richest person if you have cleaned water and cleaned oxygen or kind of air available around you. That is why I constructed my house near to a very natural environment. And now my family is happy, the kids are enjoying, and just giving you an example how much that ventilation is. So much better is to start with the design, and later on, yes, you require maintenance. You need to make sure, like we have a fixed schedule for cleaning the, the windows, cleaning the drainage system also, making sure no blockage, everything is okay. Even it's a house only. So what about the industries where we are manufacturing a lot of products or producing several products for the markets and giving or facing a lot of fumes in the air, and how we can compromise our ventilation system. I hope it will give you an idea. Our complete site layout, our buildings to be constructed, and this ventilation word should never be ignored anywhere within the building. And yes, it's required a routine inspection, planned preventive maintenance, and periodic testing as well. Like as per cost requirement, every 14 months, the periodic testing should also be there. Dilution ventilation, that means diluting the contaminant, changes the air. Passive dilution vents. Active dilution means powered fans. Working exposure limit is high, formation of gas and vapor is slow. So again, the ventilation, one word, very much detailed subject. Now it is up to you how much you want to learn technically, logically, how much knowledge you want to gain just for this particular one topic. Natural ventilation, kind of manual ventilation, or different kind of ventilations are there, like dilution ventilation. Important to know whether contaminants are lighter or heavier than air. That means accordingly we have to make sure operators are not close to the contamination. And this is just a kind of example, like open windows, look at the fresh air is coming. Same way in my house also, one way if fresh air is coming, the other way is going out also, because all the windows are interconnected. If you open one window and then the second opposite window, across ventilation is also there. That means we don't need ACs, air conditioner in my house, not a single air conditioner is there, even in summer season, Yes, but we are surrounding with big canal and also a lot of trees. So mostly we generated, if we got natural environment, so why should we demolish those natural environment even in my house, Why can't we enjoy it? Because cleaned oxygen, cleaned air, everything is okay all around. And comprehensive drainage system also well covered. No contaminants are coming in the air. I hope it will give you some kind of comprehensive example of passive dilution ventilation. But yes, there are of course limitations also, not suitable for highly toxic substances. Compromised by sudden release of large quantities of contaminants, do not work well for dust, for point sources. Dead areas may exist where there is little or air movement. Respiratory protection equipment, yes, we need respirators, we need breathing apparatus, maybe SCABA, or respirators would just have filter contaminated from the atmosphere around the wearer. Or breathing apparatus means SCABA, SCBA, or SABA, supplied breathing apparatus, or maybe EBA also for emergency escape breathing apparatus. There are some benefits and limitations also of filtering face piece regulations or respirators. Normally they are cheap, easy to use, disposable, but low level of protection. These are some limitations. Does not seal against the face effectively, so uncomfortable to wear. So these are some of the limitations of respirator. Half mask or nasal respirators, again some benefits and limitations are there. Good filtration, fit is achievable and easy to use. These are benefits. And limitations mean no built-in eye protection and negative pressure inside face piece, or maybe uncomfortable to wear as well. That is why the fit test is so much important. We have powdered respirators. That means immediate level of filtration. Air movement cools wearer, or air strain prevents inward leaks. Limitations mean heavy to wear, no light face shield, limit battery life. So if air contaminants are unavoidable, then at least the right set of respirators must be provided. Same way we have compressed air breathing apparatus or air under pressure. That means supply of air is not time restricted if a compressor is used. Positive pressure inside face piece and wearer is not burdened with cylinder. But limitations, hose can be long but not endless. So some limitations are there. And self-contained breathing apparatus or pressurized cylinder, look at the picture even. It's a complete freedom of movement. That's why this kind of rescue operations or for inspection of confined space normally we use, or even for firefighters, normally we use this self-contained breathing apparatus because it have positive pressure inside face piece. But limitations, supply of air is time restricted. We can't use it for 1 hour or 2 hours or 3 hours, it can only be used for, like, it's designed for 35 minutes, but we use for 20 minutes or 25 minutes or 10 minutes. We still need to come out from that danger zone. Even though the equipment is bulky and heavy, that is another limitation, and more technical training is required. How to use it, how to wear it, especially in 30 seconds. So these are some of the best methods in selection and use of maintenance of respiratory protective equipment. These are some of the factors, like consideration of the contaminant and its hazards, physical form of the substance, level of protection offered by RP, respiratory protection equipment, and also presence or absence of oxygen, duration of time that it must be worn. Compatibility is critical with other items of PPEs, shape of the user's face, facial hair like mustache or beard. Normally, while using this respirator is not acceptable, because any gap or the rubber is not fitting on the face or it's misfit. Again, the terrible contaminant of air can go and mix and go into the lungs and creating horrible outcome. So physical requirements of the job, physical fitness of the wearer is also important. Users should understand how to fit the RP, how to test, what are the limitations, cleaning requirements, and most importantly, the maintenance requirements, especially how to change filter. Other personal protective equipment, we have hand protection, eye protection, body protection. You all know already, mashallah. And that is why this all 16 sections of STS safety data sheet are important, because from where we can get what kind of PPs we have to use. Personal hygiene and protection regimes like hand washing in routine, care for removal, disposal of PPs, and no contamination must be there, especially along with the normal clothes. Eating, drinking, smoking, especially in that working area, must be prohibited. Washing facilities, changing facilities, rest and food preparation areas. Personal hygiene, that is why, not only industrial hygiene, even the personal hygiene is another huge subject. Vaccination against biological agents like hepatitis B, and also we have against COVID-19. So any connected disease, we have to go for vaccination. And yes, we required worker consent required, but for coronavirus, it is being enforced, that without vaccination, you can't move to several countries or even cities. Immunity not always achieved, false sense of security also. We can have some health surveillance. These are logical points. Mashallah, I hope you already have some understanding. Health monitoring, since you have annual screening or medical screening of your employees. But since make sure you have health monitoring, biological monitoring, as well as screening of first employment. That means before you hire anyone, make sure the complete medical reports is providing you. Kosh will be helping us, especially for working exposure limits, and also the 8 principles of good practice which need to be applied, and most importantly, exposure is controlled as low as is reasonably practicable in halal. In addition to the standard control measures, the following must be considered, like total enclosure of process or handling systems, prohibition of eating, drinking, and smoking, regular cleaning, warning signs, all are basically administrative controls. Safe storage, handling, and disposal also. We will start specific agents tomorrow, inshallah. Or if you have some energy, we can wrap up even today, but it is little bit very much a deeper subject, because asbestos is there. So it's better we will discuss with fresh energy tomorrow, inshallah. Is it okay, or you want it to finish today? I mean, it's up to you. I'm still ready, and it's 2:30 yet. If you have energy, we can move on. Otherwise, please give me your opinion, because let's not to be overdosed. A lot of knowledge and informations are there, even though hard to remember. Okay, this theoretical part, especially when we talk about administrative rules, or this should be done, this should be done, this is the rule, this is the rule. It's a very lengthy stories and even hard to remember, by the way. But still, we are bound to read and understand. So yes, I agree today, a little bit extra knowledge we share to each other. So tomorrow, inshallah, we will start from the specific agenda 7.5 of element 7. Okay, guys, thank you very much for your great patience and your great energy, mashallah. And see you tomorrow, inshallah. Thank you very much.